Now I introduce the policy and the value functions in reinforcement learning. A policy pi in reinforcement learning is a mapping strategy. Let me say it maps from states to possibilities of selecting action A. And it's, for example, from this state, this player, this ball, this call state. The policy is how can we select the action to hit the ball, reach the destination point. Policy is how to select the action under policy pi. To evaluate policy pi, we need to define two value functions. One is a state value function V, another is a action state value function Q. This state value function, say start from one state, we have a policy pi. Under this policy pi, we have many possibilities to select action A. And follow each A, we have an episode to calculate the future discount reward. Because once we select this A, environment use this state transition probabilities to respond to the agent, get this reward and reach the next state as a prime. And follow this way, we get a trajectory, get a return. We cannot use future discount reward along one trajectory to evaluate the policy because environment is dynamic. So next time, even our agent selects the same action because the environment changed. So it may reach the different next state. That's why we need calculate the expectation of the future rewards over all the possible trajectory. And then we got this state value function. And then later we introduce how to use this state value function to evaluate the policy. In a similar way, action state value function Q is not only evaluate a policy at the state S as a value of state S and action for under the policy A as a pair, and then follow the same policy and calculate all the future discount reward along all the possible trajectories. We calculate the expectation of this future discount rewards over all the trajectories under this policy pi. We got this action state value function. And then we can use the Monte Carlo sampling to evaluate or calculate, estimate the state value function and the action state value function. This is the formula we start from this current state. We calculate the return reward for each state, and then we calculate we get the future discount reward along this trajectory, and then we calculate the expectation of the future discount reward over all the trajectory under policy pi. And the similar way, we calculate the action state value function for each trajectory. The expectation means, for example, for policies, it's because under this policy we have so many possible. Then now we calculate the the average over the action, we get the expectation of the policy pi. For the Q function, we evaluate policy at state S action, select action A from policy pi, and we are, from this state transition probability, we got the next state, then we follow the same policy pi, we calculate the expectation of all the trajectories and follow the Monte Carlo sampling, we can calculate the Q value. Bellman equation is just recursive of the recursive formulation of state value function from state S to state S prime. Similarly, for the action state value function for the Bellman equations is the same thing. We get a recursive formulation for action state value function at S and A, and this action state value function at S prime and A prime. They just these two Q at S prime A prime relationship. And because under a different policy, we have a different state value function. So what we need to find the policy pi, which produce the biggest state value function. That's state value function as an optimal state value function. And the same thing, same way we find the optimal action state value function for the optimal policy pi. Two optimal state value function and optimal action state value function, they follow this formulation. And you see we have optimal state value function at state A. We have action state value function here. Both the optimal format, they have this relationship connected by this action, actually by this policy pi. Since the state value function satisfy the Bellman equation, because this optimal state value function is one kind of state value function, the special value function. So this optimal state value function still satisfy the Bellman equation. For the same reason, action state value function is optimal action state value function is also satisfied with the Bellman's equation. This optimal value, at state S prime, and this SA is S prime SA. They still satisfy their Bellman's equation. For more details, please check with this reference. Thank you. Bye.